Everybody. Good evening, guys. How are you all doing? Welcome to Vedantu. I hope you all are doing amazing. So, we are starting with a new chapter, Thermodynamics and Thermochemistry. So, I hope everyone is good. Hanji. Chapter is terrifying, ma'am. Okay. Any more comments? Okay, so seems like you guys have already a phobia of this chapter, thermodynamics, है ना? Excited? Okay. Good evening, guys. Good evening. The chapter, how big is the chapter? Students are asking me. Okay. Hanji, very interesting. So, first of all, you all can say hi to your class teachers. We have Suryakant sir and Nitin sir. We'll be starting with the session. Okay? Yes, Harshpida, we have done gaseous state, which was required as a prerequisite only. है ना? In the end, when your other chapters of JEE main syllabus, we cover first. And after that, the chapter which are not in the new NCRT, we will cover in detail. Okay, gaseous state is a part of deleted syllabus, so we will do it in the end. Okay, that's nice, Lakshita. Hi, guys. Hi. So we would be starting with the session. I'll be turning off the chat box. Ready, everyone? Hanji, are you all ready? Have you started with the thermodynamics in physics? Tell ma'am. Hanji. Okay, in physics, have you started? No. Oh, that's good. Hena, so there is no confusion like in your mind right now because you haven't started that. Okay, chale. So I'll be turning off the chat box. Guys, go in the statue mode, say bye to the chat box so we can start with the session. Okay? Hanji. Okay, chaliye. So the chat goes off now. So you are in the statue mode, right? So see, thermodynamics, the nature of the chapter, I'll discuss. But if in case you are attending my session for the first time, so my name is Shilpi Kaushik, and today I'm not wearing Vedantu t-shirt because I've asked the team to send me a new one. So old one, may like all the print is like just taken off. So anyway, ma'am is like violating the rule. So, Veda, first of all, talking about the nature of the chapter, if I tell you in the JEE mains, so JEE mains they ask very direct questions from the thermodynamics. You can say the formula based kind of questions, right? So, if you know the basic concept of the chapter, you know the formulas, then you can solve the mains questions are like very basic level, okay? But the questions that they ask in advance are not the basic level questions, okay? So they are good level questions in which they intermix the concepts and frame a good kind of question which would require time basically and a very strong conceptual understanding, okay? This chapter will not be very much calculative. Like if I tell you in class 11, then ionic equilibrium ke questions are most calculative. We are yet to start. Thermodynamics is not that lengthy in terms of calculation, so you still have an upper hand in the chapter, right? The chapter is very important from the advanced point of view, right? Advanced may I told you that in 2021 they asked 3 questions, okay? When I say 2-3% weightage on an average, you can say 3% weightage means 1 question, okay? Thermo say you will always see around 1 to 2 questions in your JEE mains. है ना? JEE mains में you can see the weightage is like they can ask up to 2 questions. ठीक है? 2024 का weightage I have not added, so I want to tell you 2024 में thermodynamics का weightage was less. Okay, even in the JEE mains there were some shift in which they did not ask a question from thermodynamics, and even in advance the weightage was not good comparative to the past years. Now that tells you ki in the coming years they would be increasing the weightage, है ना? So it's a chapter, if they didn't ask in 2024, they are for sure to ask in 25 and 26. Okay, so you guys would be 26, may you would be expecting good questions. This is the past weightage in front of you. Okay, so now you have to see for the mains level also 1 question will come, and advanced may up to 3 questions we can have. So we have to do this chapter to a very great significant level. Okay, thermochemistry is also like a part of thermodynamics. Thermochemistry say they do not ask question every year, so it's like on and off kind of thing. So in some of the few shift they give a question from thermochemistry, and in alternative years usually we have seen. Okay, so we would be starting the chapter from very scratch. There would be around 11 sessions scheduled, so just try to not leave a class. There would be time in the chapter when you will feel it's not interesting, I'm not able to understand. Just stay strong there. Okay, because thermodynamics ka, I don't want you to go into a backlog of this chapter, because it, when you studies it by yourself, then you find the chapter a little boring, like lot of students, right? And for engineering point of view, you should do thermodynamics. If I tell you about mechanical engineering, so mechanical engineering with all 4 years, it's huge level mathematics that you deal with in thermodynamics. And chemical engineering mein you have to study it for around 3 years. Okay, baki engineering mein for first few semesters you have this, and at least for 1 year. So thermo is something that's going to follow you if you are going into btech for sure. Okay, so just it's better to be in good terms with the chapter. Most critical topics from where they target the maximum questions, number one is heat capacity. So whenever I will teach you this topic, you have to be extra alert. Okay, heat capacity, say they ask a lot of questions. The second thing is the calculations of the work. Okay, so I'll mention calculation of work done, calculation of the work done in the different processes. So there would be different processes that we would be studying in the chapter, like isothermal, isochoric, adiabatic. So exam mein they ask questions about the work of those processes, है ना, work calculation. The numericals are very basic and like require the concept knowledge. And the third part is entropy. Okay, so these are the things we are going to like find most important in the chapter, so just be active over there. You know, so we'll be starting with the basic terminology. So today's class is like very basic class, you know, so you would not be getting the feeling of the in-depth thermodynamics, but we would be starting from here. Okay, so there would be very basic terms, the introduction, the processes, which is the base of the chapter, right? Which is the base of the chapter. I think there's no confusion so far. You understand the nature of the chapter to like some extent now, you know. Okay, so it's like it's not a very bad and pathetic chapter which you think in your head, "Arey, this is thermo. We don't want to study thermo." So it's going to be interesting. Okay, so first of all, we'll understand the word therm means heat. Okay, therm means heat, and when I say dynamic, dynamic means motion. Right, so the term tells you that we are going to talk about the heat motion. Matlab, what is heat motion? We are going to talk about the movement of the heat or energy, you can say. Okay, so it deals with the study of movement. Okay, motion tells you about the movement. Now, whose movement are we talking about? The movement of the heat or energy, right? So how heat or energy would be moving in the macroscopic like objects basically, है ना? So macroscopic bodies में we would be understanding the motion of the heat, the motion of energy, the interconversions of energy, right? How energy would be converting from one form to another. For example, when you are burning down a coal, you are burning a coal, after some time it turns reddish in color. So how exactly energy transfer is taking place in the process, right? So we deal about that. So thermodynamics deals with the macroscopic bodies. Okay, macroscopic bodies and their changes, their heat and the energy changes that we would be studying. Okay, so that is the basic motive of it, and it also tells you about the feasibility of a process. Okay, ki whether a reaction is going to take place or not. For example, if you talk about rusting of iron, okay, so thermodynamics is going to tell me whether rusting of iron is a spontaneous process or a non-spontaneous process. Like for any change that is happening around you, thermo tells you about its spontaneity. What do I mean by spontaneity? Spontaneous process is a process which is going to take place on its own. For example, if you take out a refrigerated water bottle from the fridge, you keep it on your table at the room temperature, you know what is going to happen? Eventually the cold water bottle is going to become hot after some time. Yes or no? Yes, the water is going to come at the room temperature, isn't it? So it would be the same normal temperature after some time, isn't it? So can you tell me the flow of the heat? What is the direction of the flow of heat? Tell me. Hot to cold or cold to hot? High temperature to low or low to high? Very good. Yes, Akshay, you can. Guys, you can attend the session. If you have not attended gaseous state, it's okay. Okay? Low to high, high to low. Think about it. Low to high. How heat transfer is going to take place? There is a like, I see lot of students saying high to low, low to high. You are having a water bottle है ना, which is like ice cubes वाला water bottle. At room temperature it eventually comes down to the room temperature only है ना. If you keep it like now, if you take a refrigerated water bottle, after some time it will become hot. If you see the flow of water, let's say we talk about the flow of water, so water spontaneously comes from upward to the downward direction है ना. जैसे you've seen waterfalls, तो waterfalls में what is happening, water is flowing down है ना, from height to the like deeper level. But if we have to do the reverse flow of water, if I want water to go from here till you have kept a water tank at your home, so you need electric motor to do that है ना. That is non spontaneous process. Non-spontaneous process would require your interference. You have to initiate them, then they would be happening on the own. But spontaneous processes are which are taking place themselves. So here comes the importance of thermo. It tells you whether a reaction, whether a process is going to be spontaneous or not, whether a process is going to be feasible or not, a reaction will take place or not. So these things thermo will tell you. Just say for example, if you see rusting of iron, so iron gets rusted on its own, but provided if you have oxygen, if you have water, air and moisture both should be present so that iron can rust itself है ना. So what happens on the surface of iron, water and oxygen attacks and lead to the formation of hydrated ferric oxide है ना. This is rust. So the direction of a natural process, under what conditions iron will rust है ना, whether the change will happen on its own or not. So this all things thermodynamics tells you. Okay, that is the basic definition of thermodynamics. We deal about the movement of energy, the motion of energy and heat, the interconversions of energy, the spontaneity of the processes. That is what thermo tells us. Okay, whether it's spontaneous or non-spontaneous, any process. So that is the main thing that we have to do. Okay, now there are some basic terms that we would be studying in thermodynamics. Just say we are having a term system. Okay, so what do I mean by system? Dekho, I have a marker in my hand. Okay, so right now I am telling you about the characteristics of the marker. Ki the marker body is whitish in color. The marker, वैसे when I write it is having black ink in it, right? The lid is like there's a black color ka lid on the top. So I am defining this pen है ना. I'm telling you the characteristics of the pen. So I'm studying this pen right now. So that object, that part of the universe which is under thermodynamic investigation, that is known as a system. Okay, listen to me beta, you need to understand the term system because in entire chapter we would be talking about it. So system is basically that part of the universe which is under thermodynamic investigation, which we are studying basically. For example, right now your system would be your computer screen. Okay, or if you are attending the session on mobile phone, so your system right now is your mobile phone ka screen. Your entire focus should be on that screen and everything else should be just surrounding for you. You know what is happening at your home right now, who is talking to whom, you know what people are doing, what is happening on the road. You are not concerned with that because right now your entire focus is the device in which you are attending the session. So your system is this screen है ना, which you are seeing right now. So let us say I am having a water bottle, right? So water bottle would be difficult to draw. So you know Shilpi ma'am will be choosing easy drawing. So let's say we are having a beaker है ना. Beaker is filled with cold water. Okay, there is water inside this beaker and I'm studying the heat changes, the energy changes of water. So the water is going to be my system. Everything else, you, whatever, the chair, table, pen, whatever else is there in the universe, that will be my surrounding. Okay, so my system, if I'm talking about the water filled inside this beaker, so my system is going to be this water. Everything else in the universe will be a surrounding for me. Okay, so so like for the JEE preparation, your system should be what? Tell me, guys. Yes. Part spontaneous, non-spontaneous beta will come later on in the chapters. Okay? Ha, your system is going to be books. Very good. Tatva, advance. Okay, JEE syllabus. Yeah, very good, guys. Oh yeah. Hanji, very good, guys. I'll turn off the chat box. You guys have given the good answers. Very good. Yes. So if you are studying, your system is your textbook, है ना? So everything else should be a surrounding for you. Right now, my system is you guys, है ना? So I'm just focusing on you. What is happening outside in the surroundings, I don't care about it, है ना? So system is basically that part of the universe which is under thermodynamic investigation. So if I tell you there's this water filled inside the beaker, tell me what is the system. The water is the system. Second, water and the walls of the container are the system. Or let us say the air outside is the system. So what would you choose? Yes, what would you choose? What is the system? Yes, I'm talking about the energy changes of the water that is filled inside the container. So my system is water, beta, not the walls. No, it is only water. Okay, the system would be only water. Everything else is a surrounding. Okay, it would be water only, right? So how do we define system? That part of the universe which is under thermodynamic investigation, right? Okay, so we have defined it. See, देखो, the system is that part of the universe. It, sorry. So system is that part of the universe which is arbitrarily set off from the rest of the universe. We have separated it from the rest of the universe and by some definite boundaries for the purpose of experimental studies, or I would write a better definition. The part of universe which is under thermodynamic investigation, right? Which is under thermodynamic investigation, which we are studying basically, that is our system, and everything else would be a surrounding for us. Everything else would be a surrounding for us, and that part beta, that just say for example this water was my system, so everything else is surrounding, everything else outside my system would be a surrounding. Okay, now that part which separates the system from the surrounding, that is known as a boundary. Okay, like if you can see the water is my system, so what exactly separating the system from the surrounding? Tell me in this example which I have drawn here, the water is the system and everything else outside this is a surrounding. So what is separating my system and surroundings? Tell me guys, what do you see in this picture? What is separating system and surroundings? Walls of the container. Very good. Walls of the beaker. Exactly. Yes, you got that. Yes. So beta, this wall is a boundary, है ना? So I don't have my water bottle with me right now. So you can imagine, है ना, जैसे this marker. So if the content, the ink inside the marker is my system, then this wall is separating the mark, the system and the surrounding, है ना, everything else. So this is a boundary, or you can call it a wall as well, right? So they have taken a balloon example here. If the air which is filled inside the balloon is our system, है ना, we are, that is under thermodynamic investigation, we are studying the changes of this gas which is filled inside the balloon, then everything outside this would be a surrounding, and this wall of the balloon, it is separating my system, the gas filled inside and the surrounding outside. So this would be a boundary, and the outer surface of balloon is the boundary. Very basic terminologies. And overall universe, entire universe comprises of system plus surrounding, and a universe comprises of system plus surrounding. So what we have done so far, I will reiterate myself. We have seen what do we understand by the thermodynamics. So thermodynamics may we study about the changes or the movement of the heat and energy in the macroscopic systems, how the heat energy, the energy transfer, the energy interconversion, when energy goes from one form to another. So all the heat related changes basically for any system we study in the thermodynamics, है ना? It also tells us about the spontaneity of a process. Someone was asking about what is spontaneous. Spontaneous process is a process which happens on its own. Non-spontaneous processes are those which needs initiation. Just say water, if we have to rise water from like this level to a higher level, then we use then we use electric motor. The water will not go from low level to a higher level on its own. The process needs initiation, so we use electric motors. That's a non spontaneous process. you know so these processes which takes place on their own, they would be spontaneous. The process which needs to be initiated, they are the non spontaneous one. This will come in the later part of the chapter. This we would be doing in the end sessions, basically after the entropy wali cheese will start. Right now, why I've written this, I'm telling you it's an application of thermodynamics. It tells you whether a process will happen on its own or not, whether a process, a reaction will take place or not. That is the application of thermodynamics, which will come in the later part of the chapter. So just don't focus on spontaneous, non-spontaneous. And the heat ka question I gave you, the flow of heat, that also we will be discussing. So keep on thinking. Heat flows from high to cold, cold to low. Okay? Chalo. So next we discussed about some terms like any part of the universe which is under our study, है ना, which is under our thermodynamic investigation. Like I have to study its heat energy changes. That part of the universe is defined as a system, right? Which is under thermodynamic observation. Everything else is going to be the surrounding, and that part which separates the system from surrounding, that's a boundary. For example, the water, if I'm studying the heat changes of the water inside the container, then the water filled is the system. Everything else outside this is the surrounding. The walls of this glass, the walls of the beaker, they are the boundary because they are separating the system and surrounding. That is what we've done so far. Okay. Chale, now boundaries are of two types. The first, we have a real boundary. Second, we have an imaginary boundary. So real boundary, the name itself is telling you. Real boundary is like, for example, this is a test tube. है ना? So test tube में I have filled a sample. Okay, let's say I filled an alcohol. So this glass that you are able to see, है ना, the glass of the test tube, it's a real boundary. You can see that with your naked eyes. You can see that it's a clear cut separation. It's a clear cut separation. So the rigid, this is a real boundary basically, right, which is visible to your naked eyes. Next, we have imaginary boundary. Like if you are having water filled inside the beaker, beaker itself is invisible right now. Chalo. So we are having water which is filled inside this beaker. So the real boundary is the wall of the beaker. Imaginary boundary is, beta, if I tell you that there are some water vapors on the surface of liquid. There are some water vapors on the surface of liquid and this is the water. So if you check the surface of the liquid, that is an imaginary boundary. The surface of the liquid which is separating water from the water vapors. Do you see a well-defined boundary there? You don't see a well-defined boundary. There's no rigid glass boundary there. That's an imaginary boundary. We say that the air is separated from the water at this point. So this is an imaginary boundary. Okay? Hanji. So air and the water ka separation. Can you repeat, please? Beta, boundaries are of two types basically. Real boundary, which is visible to you, like this. The same example will take. See, this is a real boundary. You can see the walls of the glass, they are the real boundary. We can see them, we can touch them. That is visible to your naked eye. Now there's an imaginary boundary also, this liquid surface which is separating water and the air. There is air outside and there is water inside. So do you see there's a boundary which is separating air and water? That is an imaginary boundary. This boundary. Where you know in your mind ki yes, at the surface of the liquid, water and air are getting separated. So this is a imaginary boundary, right? So we have these two boundaries. Apart from this, boundaries are divided into further types. Okay, first we are having a rigid wall. A real boundary can also be defined as a wall, so you can say wall also, that indicates the same thing. So we have rigid walls. The rigid walls are those walls which cannot move, like the wall of the container in which you have kept water. This wall is not going to move. It is a rigid boundary, it's a fixed boundary, right? It will not move. Let us say you have a balloon may we have filled CO2 gas. So this wall of the balloon is movable. If I expel out some air from the balloon, or if I start filling more air inside the balloon, the walls are going to change in dimensions. Yes or no? If I expel the air out, boundary will squeeze, है ना? If I move in more air, the boundary will expand. So this is a movable boundary. So these are not rigid, they are flexible, है ना? So you can call them, they are the flexible walls, like in a balloon we are having. So this is a non-rigid wall. Okay. Then we are having the adiabatic walls. So adiabatic walls में the heat cannot be exchanged across the wall, है ना? There would not be any heat change that is going to take place. For example, tell me guys, you use these bottles also? Yes, what is the example of it? Tell me, adiabatic wall में what can I take the example? थर्मस फ्लास्क. मिल्टन, वेरी गुड. एडियाबैटिक वॉल्स के अंदर they will not allow the heat transfer. The heat cannot be exchanged across the wall. Okay, so you can say basically they are made up of insulating material. They are made up of insulating material, है ना? The heat is not able to be exchanged like in thermos flask. We will discuss about thermos flask in isolated system also. So these are the adiabatic walls. If you have a thermos flask, so you know that the if you are putting cold water or the hot water inside them, they stay the same temperature for quite some time. Although your thermos flask are not ideal adiabatic bodies. Do you know they are not like ideal adiabatic system, because after some time, you know, the water eventually comes to the same temperature. So we assume, like I'm telling you, we assume that the thermos flask is an adiabatic system. We assume it because it depends how we have manufactured it. There are some good quality ki bottles which will keep water intact, है ना, at the same temperature maybe for 2 days. There are some thermos flasks which are cheap in the market, they will work for 2 to 4 hours, है ना? So it depends on the body to body, but in our chapter we assume thermos flask as a system across which heat cannot be exchanged. But practical life में things are little different, you know, है ना? No body is ideal body, so it's like that. So adiabatic walls में, हाँ, your thermos flask, we are writing an example कि they are made up of insulating material and heat cannot be exchanged, right? Next we have diathermic walls. Diathermic walls में beta, they will allow the heat transfer across them. Okay, so I'll write in the simple words, allow heat transfer across it. Allows heat transfer across it. You can think of a normal plastic ka bottle that you keep in the refrigerator. If you bring that bottle at room temperature, eventually, you know, water will also come down at the same temperature, hai na? The cold water will become hot, right? So that's a diathermic wall across which the heat can be exchanged, right? These walls are made up of conducting material. Made up of conducting materials usually. Jaise you are having, let's say, copper ka vessel, right? They are made up of conducting material. Made up of conducting material, like you have your copper vessel, it will eventually come down to the same temperature. Or you are having, this is your pressure cooker, made up of steel, है ना, which is also having conducting walls. It's majorly iron. So pressure cooker maybe across the walls you can see the heat transfer takes place, है ना? So these are your normal diathermic walls. ठीक है? Chalo. So we have seen the types of boundaries, real boundaries which are visible to your naked eye. So we can see them like the wall of the beaker, the wall of the container. That is a real boundary. You can touch it, you can smash it, you can break it. Imaginary boundaries, like you can see the air and water is getting separated at the surface of the water. So the surface of water, we can say, is the imaginary boundary, right? Chalo, this is the imaginary boundary, है ना, that we can see here. Then we have further different types of boundaries. Rigid boundaries are there. The rigid walls, they are immovable, है ना, they stay fixed at a point. We have non-rigid walls which you can expand and compress, like basically they are movable, right? If we talk about adiabatic walls, the adiabatic walls may the heat transfer cannot take place between the system and surroundings, right? Diathermic walls may heat can be exchanged between system and surroundings. They are made up of the conducting materials. The normal any you can say conducting material, any bottle that you're using every day, that's a diathermic wall, right? There is a heat transfer which is taking place across the boundaries of it. So these are the basic boundaries. They do not ask question in JEE ki define adiabatic wall. Obviously these are terms which will be used in the chapter, है ना? You will see a question in which they would be writing a term adiabatic will come somewhere. So this is a basic terminologies that you should know in the beginning of the chapter, so that chapter, you know, becomes understandable for you. Okay. Chale, next we have the types of system. जैसे you have done system is the part of universe which is under thermodynamic investigation, है ना? So now this system is divided into different types. The first one is a open system. Open system means देखो, there are two terms, just remember them as a word of me. Okay, I me myself. So me में m से you can remember mass or matter. Okay, whatever. And e से just remember the energy. Matter or mass or energy, whatever you feel comfortable with, है ना? Matter energy, mass energy, heat mass, any term, right? So let's say we are talking about two terms, mass and energy, or matter and energy. So a system in which we can see कि there is an exchange taking place between system and surrounding in terms of energy as well as matter. For example, if you see your, this is a water glass, है ना? I have filled water inside it. Let's say you keep this water in heat, है ना? You took a glass of water, right, and you keep this container under sunlight. Okay, so अभी तो वैसे भी the temperatures are usually high in North India's में. There's no monsoon yet, है ना? It's still so high temperature that if you keep this water, you know, like for some time outside, so after some time what will happen, water is going to become hot, the temperature will rise up, है ना? Okay, the water becomes hot after some time, keeping it outside. The second thing that will happen, beta, some evaporation is going to take place. Obviously evaporation happens at room temperature, and right now also if you have a glass of water, it is still evaporating, you know? If we keep it under sunlight, evaporation would be even faster. So what just happened, when you observe this container, so you see there are two changes which are taking place. The one is a transfer of energy. The transfer of energy, or you can say heat, took place. How the water become hot, yes or no? The water became hot, है ना? I kept a normal water under sunlight, the water became hot after some time, so there's an energy transfer taking place due to the heat, है ना? Due to high temperature. हाँ जी, very good. So first thing, energy transfer took place, है ना? The second thing beta that took place is the matter का transfer, matter exchange. How some of the water particles from the surface have evaporated out as water vapors. That means there an exchange of matter also, है ना? So these kind of systems through which there can be an exchange of energy as well as matter, they are defined as open system. It's a very simple, your glass of water, है ना, which is open, which does not have a lid. Your water bottle, if you just remove the lid, that's an open system, है ना? This tea cup, it's an open system because I can see there's a heat transfer which is taking place across the walls, and there's also matter ka transfer which is taking place. Some particles are evaporating, है ना? So between system and surrounding, both energy and matter can be exchanged. So these kind of systems are the open system. Okay, they are the open system. Next beta, we define a closed system. So how do we define a closed system? The same container, देखो, the same teacup, I have just kept the lid on the top now, है ना? This is my container, I have filled the glass of water and I cover it up with a lid. So now what will happen, the heat will still, tell me, the heat energy transfer is still going to take place across the walls, and heat or energy will still be exchanged between the system and surrounding. But now matter cannot be exchanged, है ना? Matter का transfer is not going to take place now because you've covered it from the top, है ना? So energy can be transferred but matter cannot be transferred. This is a closed system. Okay, this will be a closed system, right? The next kind of system we have is the isolated system. Beta, isolated system mein what will happen, matter and energy both cannot be exchanged between the system and surrounding, right? Matter as well as energy, they cannot be exchanged. Like your thermos flask mein you are having the insulated walls, है ना? So across these walls beta, heat transfer does not take place, energy transfer does not take place, and matter also, obviously you've covered it from the top. So these are the isolated system across which matter or energy transfer cannot take place. Are you understanding? Anji, yes. Okay, awesome, awesome. So this is the easiest part, है ना? Okay, चलिए बहुत बढ़िया. So बेटा यहाँ this is clear. I think isolated में matter energy both will not going to transfer, and I tell you already we have discussed this thing कि actually practical life में no system is ideally isolated, but thermos flask will be assuming it is isolated, right? So perfect isolated system, you know what is that? Universe. You should note it down in your notebook. Universe is a perfect isolated system. It's a perfect isolated system. Yes, across the universe, we do not have the exchange of matter or energy. You know, like this will not happen if we are going from one planet to other. So we would be taking off some matter from our universe, है ना? Like overall universe के बारे में I'm talking about कि we have universe as a perfect isolated system. Okay, universe is considered to be the perfect isolated system. Okay, so guys, have you seen that movie Doctor Strange? Yes, have you guys seen the movie Doctor Strange? Yes, the multiverse of madness. Have you seen that? Ha, yes, multiverse madness. Okay, lot of you are saying no. Okay, chaliye. Hanji. So, if you have seen Avengers, so you know what Doctor Strange did. Like, lot of you have not seen that, so just see wherever you get time. है ना? The science fictions, so you guys should see anyway, right? So you will, मतलब, that will make your mind go like you know more curious कि how this is happening, how Doctor Strange is basically, है ना, like going from one universe to another. So actually, Doctor Strange में, if you see, my pen is lagging. Wait a minute. हाँ. Yes, parallel universe. So, Beta, what Doctor Strange has done in the movie, they have shown the transfer of both mass as well as energy. They have shown the transfer of both mass and energy, but that is not possible. Like in real scenarios, what Doctor Strange is doing is violating the energy conservation, right? Because they have shown the concept of parallel universe, but actually we do not have a parallel universe ka existence known to us so far. So that means universe is not exchanging energy or matter with another universe. है ना? We don't know parallel universe is there or not. So how can we show the matter and energy ka transfer? So we assume and we take universe as a perfect isolated system. Movies mein though they have shown the parallel universe ka cheese. So what Doctor Strange do is the transfer of both mass as well as energy. है ना, which is not like true because we think universe is isolated system, energy conserved. अगर ऐसा हुआ, the mass energy transfer can take place, then energy conservation will violate obviously, है ना, and we'll have real issues. But that does not take place movies में तो anyway, है ना, they show anything. Chali. So now next we will talk about the state of a system. So there are some, again this is the basic terminology going on. So let us say I have filled a gas inside the cylinder. है ना? There is a gas filled inside the cylinder. So how can I define the state of a gas? How can I define the state of a gas, beta? If I mention the pressure of the gas, है ना, कि gas which is present in the cylinder is right now at this atmospheric pressure, है ना, it is stored at this pressure, right? Or if I define the volume of the gas inside the है ना, inside the cylinder, or the temperature or the amount, so they all are defining the state of the gas. Yes or no? They all are defining the state of a gas. है ना? तो state of a gas we can define, we can tell if we are going to mention the pressure, the volume, the temperature, the amount of it, and the amount of substance, etc. So all these things are going to tell you about the state of a system. Something like this I told you in the gaseous state also, but if in case you have not attended, that's okay. And in the entire chapter I'll tell you what will be our system, है ना? Our system in this chapter, thermodynamics study point of view से I'm telling you, there would be a cylinder given to you. Cylinder may we have filled a gas. Okay, so this is a piston at the top, right? We can like increase or decrease the pressure over here. So this would be, this gas is going to be our system in the entire chapter. You know, this, the gas which is filled inside this cylinder will be the system for us. So we will define the state of this gas by mentioning the pressure, the volume, the temperature, the amount, etc. Right? So now if I tell you about the basic, there are two kind of functions which we would be studying. The one, we have a state function, right? Just say I'm telling you how can we define the state of a system. If I mention these variables, that will define the state of the system, and these states can be further, we are going to see them into two different types. We have the state functions and we have the path functions. Just listen to me carefully. Beta, state function is a function which depends only on the initial and the final point. Like let us say there is a state of the gas which is right now present at pressure P1, volume V1, temperature T1. Okay, and there is another state, pressure P2, volume V2, temperature T2. So state function is that function which is dependent only on the state, on the initial and the final state. It is not associated with the path that you have followed to achieve the state. Like how I have taken the gas from point A to point B is not going to be a matter of concern. Ki if I take A to B state by this path or by this path, or I'm going from this path, doesn't matter. These kind of functions are only going to depend on the state of the system. It is independent of the path that you have followed to attain that state. So these kind of functions are the state functions. And in chemistry, in the chemical thermodynamics, there are seven state functions that we have to study. Okay, there are state functions. How many state functions? Yes, tell fast. There would be seven state functions that we have to study. Okay, yes, are we clear on this? Hanji. Message is clear. Okay, thala for a reason, Okay, chaliye, very good. Hanji, chaliye, awesome. So I will repeat again. Beta. I'll repeat the entire class. I'll keep on giving you summary. So I have my short notes also, handwritten notes. I'll also give you summary. So don't worry. Okay, don't worry. Hanji. चलिए, so देखो, I was telling you कि those functions which are going to okay, I think I was disconnected for some students. So pay attention, beta. The functions which only depend on the initial and final point, not on the path that is followed to attain that state, they are the